So hi, my name is Stefano Gridelli, and I'm the co-founder and CEO of NetBees. For those of you that don't know NetBees, we do distributed network monitoring. And today, since we love distributed network monitoring and we're at Mobility Field Day 1, we want to talk about distributed network monitoring for wireless metropolitan networks. So a little agenda for this session. First, I'll compare and talk about centralized versus distributed monitoring. I'm sure most of you are familiar with at least centralized monitoring. And second, talk about a little different kind of wireless metropolitan networks. I'm sure here we have a lot of expertise in the room about this topic. And third, about how to apply distributed network monitoring in the monitoring of wireless metropolitan networks and why it's important and how it can help. And lastly, open discussion. I would like to hear your opinion and feedback on this topic, but most importantly, feel free to interrupt me like anytime during the presentation and let me know right along the slide, the presentation, what you think, and if you have questions. So centralized network monitoring is something very familiar to us. Mostly is based on the standard SNMP, the Simple Network Management Protocol. And generally, in a centralized network monitoring environment, you have one server, which is an SNMP poller that queries periodically and continuously network equipment, whether are routers, switches, or servers. This poller gives us information about the device itself, statistics about, for example, bytes in and out, the interfaces, CPU and memory consumption. And this was really developed like in the late 80s, early 90s, and it was really associated with network monitoring. And generally, the information is exchanged and transmitted through MIBs, where is the definition actually of the actual data that we can obtain from a device. And if you think traditionally, most of the networks, enterprise networks, were designed in a hub and spoke fashion. So there was always a hub site, which typically was the data center, and then multiple spoke sites, which are the branches or remote offices. And generally, they were connected with a dedicated or leased line, whether it was ATM, ISDN, now T1s and MPLS. And for this monitoring of this type of infrastructure, SNMP was doing a good job because it gave us, bottom line, the network status. There was really one link to reach out an end user, a remote router or switch. So that would also validate not just that the network equipment was up and running, but also that users had connectivity. And also on the data center where the server is installed, typically, you can also run always sometime ping test to the internet to verify network performance to the /0 to the internet in general. However, things are changing nowadays. We see always more kind of split tunnel environment where also the remote offices have their own internet connection. They don't use anymore the common uplink or connection at the data center. They have their own internet connection, same like at the data center, and then eventually they will establish a private tunnel across the internet to the main office. So as you can imagine now, monitoring network performance, connectivity of remote users is much more challenging because what you see in the data center is not necessarily what your end users see at the remote branches. So generally, our server can say, yeah, at the data center, everything looks fine, but you might hear complaints from remote users. So it's really important to detect those problems, and that's why monitoring is deployed generally to be alerted in time. So here's where come into play small hardware agents or software agents, but it's like a little server installed at each remote office. And by doing so, not only have the monitoring from the data center, but also at the remote location, now have that perspective into network monitoring. And by deploying a monitoring device out there, that also probes the network. I can detect and measure internet connectivity, network performance, both to the enterprise, to the hub, but also to the internet. And this is where distributed network monitoring comes into play. So we have like now for each location a monitoring device that is telling me what is the network performance there in an end-to-end fashion. So now I have a much better information about latency and packet loss. So enters the wireless metropolitan networks. And I'm sure here we have a lot of knowledge about wireless, and see, you guys have seen a lot of like probably wireless metropolitan network deployments. And there are really different kinds. And here are probably the most common is like Wi-Fi hotspots. And actually going up or down, we see that basically the centralizations decreases and it's more decentralized. So for example, a Wi-Fi hotspot is owned by a single organization. For example, like Xfinity, they are deploying a Wi-Fi hotspot all over the place where they have a subscriber. They also broadcast a kind of a public open SSID. That's their way basically to get more users into their network. But there are also like local entities, cities, but also private advertising agency that are offering these services to, or little ISP also that are offering these services to basically bring in subscribers. But in this type of deployment, it's still like 802.11, it's still like one access point with a default gateway and a router attached to it. And it's very simple. It's highly centralized, even if these networks can be spread across like the entire country or an entire city. And then we see mesh networks. And this is something, a new trend that is getting, it's very interesting. In a mesh network, as you see in that slide, you basically have not only like a single access points that have a default gateway, but you have a mesh or network of access point that they exchange routing updates, and they basically jump through hoops to get to a default gateway. So the beauty is that you can extend a wireless infrastructure across a metropolitan area, and you don't need like necessarily an internet connection at each point. And this is very interesting also for us because we'll see soon that monitoring these networks and providing services to these networks could be very challenging. And third, there are MANET, which are mobile ad hoc networks. Any of you is familiar with the MANET? Have you ever heard? It's pretty like experimental, the military are using, for example, MANET when they go in areas where there is no infrastructure and they need to exchange communication between nodes. So it's completely an ad hoc network, and it's very interesting. Right now, we're not aware, at least myself, of actual MANETs with infrastructure that are available, I would say. But I'm sure eventually that could be the future of wireless connectivity and also of internet connectivity. If we think that the density of wireless users is increasing, really, we could really bridge and send a packet from here to the other side of the country, just hopping through wireless nodes.
We're talking about vehicles doing that as well.
Also VANET, exactly. Vehicles could be maybe a driver, a trend for the deployment of MANET, which is a more specific use case, right? And there is a lot of research also on routing protocols for MANET, like all link state, but also opportunistic type of routing protocols. Are you familiar with any specific networks MANET deployed? Right.
Not in production. It's everything I've heard has been theory.
Mm-hmm. Right. Yeah. So here are some of the past and present experiments about. I would like to talk maybe more about mesh networks. Is what we're seeing more being deployed. There is not the traditional, I would say, infrastructure type of wireless. For example, Meraki, some years ago, they gave away a bunch of wireless routers to the city of San Francisco because there was a gap in the city of San Francisco to offer this kind of service. And if I remember also the work with Google to provide basically an open network, a wireless network to the population of San Francisco. And you can find a lot of literature around there. Another interesting experiment was Burning Man. There was Matt Peterson in a NANOG 62 meeting that he talked about how they were able to establish this temporary mixed wired and wireless network. And if you're not familiar with Burning Man and with that talk, basically it's like the Burning Man is an event that happens at the end of August, and it's in the Black Rock Desert, and basically they build this city within 10 to 20 days. They provide services, emergency services also, and they provide wireless connectivity to their users. And it's incredible what they did there in that, such a short time they were able to build this infrastructure where basically they were using wireless network and mesh to provide extend this network connectivity. And then there are, which were a NetBees looking with interest, wireless community networks. And this is like spontaneous type of networks that use mesh technologies. And we see, for example, here in Oakland, there is the Oakland Mesh Network. Also in New York City, also there is an experiment, the NYC Mesh. And at our house in Pittsburgh, there is the Pit Mesh or a Meta Mesh, they call it. So we're looking actually to talk with these guys to do a test bed for NetBees and how we can help them basically providing a better service, because we'll see soon there are challenges in a mesh wireless network. So what are the challenges? I'm sure, first of all, connectivity and reachability. Because they're not temporary, but they're spontaneous network or community-driven, there is no SLA in this type of networks. So connectivity is really, it happens if someone has next to you an access point. So you can have your own node and participate to the network and maybe have a default gateway. But if you don't have a default gateway and you want to go through the infrastructure to reach the internet, then you have to make sure that there is someone enough close to you that can basically route your packets to an internet gateway. So of course there are challenges in reachability, and those access points can exchange different routing protocols to assure routing, bottom line. As you can imagine, performance also is a challenge in these networks, because there could be, of course, interference, and the interference is not only localized between here and the access point, but along the way, you're more subject to performance issues, because if you're not going through a cable, your packet will go through more interferences, bottom line. And of course, service continuity, it's also there a challenge. Let's imagine like we have a mesh network where the nodes are residential users, right? And sometime when you go maybe on vacation, you shut down your router, right? Now, perhaps you're introducing a point of failure in your network. So in this type of networks, there is no assurance, no service level agreement for service continuity. So it's really important monitoring to constantly be aware of what's going on in your network. So how does distributed network monitoring come into play? First of all, if we deployed hardware sensors equipped with a wireless card, we can, in multiple points of this mesh network, we can constantly verify connectivity and reachability, right? We can not just by surprise hear users complain that they cannot connect to this network or drive with a vehicle and do a site survey. We can 24/7, virtually every second, be aware of what is the status of this network throughout the metropolitan area, throughout the city, and if the service is available, and make sure we can reach the internet and the default gateway. Second, we can also track end-to-end latency. So it's important to verify performance that meets minimum requirements, at least for users to have actually a good enough service to browse the internet and provide basic services. If the goal is just not to have an experiment, but actually offer a service, we want to have a constant eye on end-to-end latency and packet loss, for example.
So, but you're talking about end-to-end latency, and especially in a multi-hop mesh network. How do you get visibility into the individual mesh links or the individual hops that you may be looking to diagnose, other than to saying the the branch of this mesh network is having a problem? Are you looking to have multiple sensors along every single mesh node? Are you looking to drive this into infrastructure gear so that you can run it as an agent, or what's the long-term goal for getting that fidelity?
Right, good question. So one could be, for example, Traceroute gives you hop by hop. And generally in a mesh network, you go through multiple hops. But second, yeah, you would install agents. You can install software agents within the router/wireless itself. Or you could have also end-user clients, right, that connect to the network. So it's a mix and match of probing with Traceroute, but at the same time also where you place your agents.
Okay.
And another is like do periodic site surveys. So with an agent like this, you can always periodically read local broadcasting networks, see if there are like new networks coming in and maybe causing co-channel interference or inter-channel interference. You can do that with distributed agents that periodically scan the network and verify that. Again, you don't want to like drive continuously around your network or hear complaints from your end users. And four, of course, identify, that gives you the capability to find dark spots in your mesh network. Of course, ideally, you would like to have a dynamic heat map, and generally oftentimes is generated by the access point itself, but you want also an external device that confirms basically that heat map. So it can give you some DBM information, the channel, and so on. So you can have a better picture of the wireless coverage of your mesh network. So here are some tests that you can configure on your wireless agents to implement this distributed network monitoring. With the ping and trace route, for example, the goal could be to start pinging other mesh nodes. And of course, the agent can be installed as external or within the access point. So you can ping other mesh nodes within the network. So at least it gives you a better understanding of infrastructure, end-to-end latency, and reachability. Second, you can ping the internet gateway to see what exactly exit point that your clients will go through. You may have more than one internet gateway to redistribute through SPF. So you want to make sure, of course, where, based on the location of your users, which are the default gateways that they will reach. And then also internet targets. Of course, if you're providing internet services to your mesh user, you want also make sure that they have connectivity to the internet and what's that performance. And perhaps you can compare that with the performance to the internet gateways. So you can compare, is this a problem within the mesh network or outside the mesh network?
It almost feels like you need to be looking at the protocol and starting to capture things like retries that you're seeing in the air. Because a lot of this is if it's green, it's good. If it's not green, you're not entirely sure where to look.
Right, exactly.
And so, like, I feel like you're headed down the right road, but I feel like you need to be a little bit further down the stack.
Yeah, this is complementary, of course, with SNMP and packet capture, or passive sniffing of wireless.
Do you have a packet capture or passive sniffing box that you feed into the cloud?
We don't NetBees, but there are solutions out there that you can use. Eventually, the goal would be to kind of start a TCP dump, process on the agent, and then, upload that with a third-party, maybe integration tool.
Or even if you pulled a packet capture and took stats off of how many retries you saw and then fed the stats up, right? You don't have to feed all the packets up into the cloud. It seems like a pretty easy to get metric for you.
Yeah, we could do that. Of course, the agents don't have a lot of CPU, so the trick would be capture, then send it to the server, or at least apply some filtering on the agent, and then send it to the server processes it and gives you the statistics, yeah. Another thing, like we were talking with the PitMesh guys, was, for example, know how many users in real time you have on each access point. So that's probably something that maybe with the syslog and also integrate that information into the monitoring. Of course, what we do, NetBees or any like active monitoring does good detection and good performance and latency measurement. So it's like the canary in the cave that gives you quick detection of problems, and then use other tools, right, to go drill down more into the problem. Yeah. So to continue, DNS, of course, is another service that is extremely important, so you want to keep an eye on that. And of course, we can always start a DNS query every 30 seconds, for example, making sure that all the users can, use DNS. And same for HTTP GET. It's a simple GET, but it gives you at least feedback about performance of the HTTP protocol, at least. So you can see, make sure that you retrieve the page and you don't have any surprises. And of course, bandwidth and jitter tests. Bandwidth is something nice. Of course, you don't want to clog your pipe, but perhaps every 30 minutes or every hour, you want to check what is the bandwidth that your network can deliver. So Hyper, for example, is a great open source tool that you can use to periodically run speed tests, a TCP or UDP based. If you use the UDP based test, maybe with the DHCP marking 46, you can also check out the jitter. So to see perhaps your network can also deliver VoIP traffic, and the result is not too bad. So that could be also a use case for monitoring.
What about emulating like a voice client, like whether it's a Skype call or a SIP endpoint or something like that, and point it at a call manager and say, make a call?
Is that with NetBees?
Yeah.
Okay, so we don't do call simulation right now. We just do simply UDP kind of packet generation, yeah. So we use basically Hyperf, we integrate with that. We send an Hyperf stream, you can set DHCP 46, and then maybe limit to 64 kilobit per second for 711, and then you have a pretty fair measurement of jitter. And then on top of that, there is also there is an open source MOS algorithm that you can use that basically use the average bandwidth, packet loss, and jitter, and then it obtains for you the MOS score. So that's something that it should be pretty fairly reliable. Yeah.
So you mentioned the bandwidth every 30 minutes. You can't have that be a scheduled test right now, can you?
Not right now. Yeah, good point. Not right now, but we're working on that.
Okay, because that was one of the things when I was running it at home, testing it with you guys, is that was the key thing for me, is because all the other pings and tests and everything, they're great.
Yeah.
But at least from a wireless monitoring perspective, one of the key things I really wanted to know was just periodically what was the throughput that was capable on that cell, for example.
Yeah, exactly. So we have it actually in the roadmap, is the next in line.
Okay.
And another one also, there is a kind of commonly available speed test CLI command. You can also run that periodically. It uses O-class servers, so you can see download and upload. And the beauty is that you don't have to bother an end user. You can just run it. One thing we push on NetBees is like access to the console. So you can, kind of install your own script and right now execute some commands. But then in the future, there will be more custom commands you can run and then have all the data nice and easy on the dashboard. Yeah. I didn't put here too much about NetBees. I kept it more like a generic, but yeah. Okay. Any other option for testing that you think might be useful for the wireless and mesh networks?
Well, you don't mention it, but it gets done depending on how you depending on how you set it up to begin with. But like 802.1x authentication.
Yeah.
I mean, that's huge.
Like a periodic authentication,
Exactly.
the association or reassociation, right?
Yep.
Yeah. Right now in our case, and that's important. In our case, right now we do just you associate. You have to do it manually. Basically, it's not nice.
Exactly.
Right. So have it like periodic. That's also something we're looking into.
And I feel like if you did off-channel scanning and started gathering stats about the RF that wasn't necessarily on the channel that you're leveraging, you could start to gather some stats around, is my infrastructure selecting the right channel in this area? And general RF health, I think, is probably missing.
Airtime, bits per second.
Airtime, CU,
So airtime is something where you need a little more hardware, specialized hardware to do that, because out of the box, like Linux doesn't do it. So I know there are different products, cards that do that, but basically they put the card in passive mode, right? So that you would need either you switch the agent to wired only and use the card to do that, or you need another dongle in the end, right?
I know this is product specific, but is it either wired or wireless, or do you hardwire in and it's doing tests over the air?
Right. It's so when an agent is wireless, it's only wireless, but the control channel could go through the wired. If you unplug the control channel, it will hop to the wireless. So that means you can attach it to a drone with a battery pack and go around and do a kind of scan of your kind of site survey. I wonder if we'll see something like that. I don't know if the drone maybe engine causes interference maybe, but that's another story. Yeah. Okay. So the benefits, of course, is that you have quick detection of problems, right? You're not waiting for the users. The beauty of active monitoring is that it's much faster. You send packets every 5 seconds, let's imagine. So the detection, if you have a multiplier of 5, in 25 seconds you can detect a disconnection, for example. And also the agent, if it drops off the dashboard, it can already tell you that there are problems out there. And of course, we'll keep storing locally the data. But then, of course, reachability and latency information. I believe the more, the better to a certain extent, without going too crazy. We'll see why, because scalability issues, but by having a better picture of your network, like almost Google Maps, you have a better understanding of your coverage of your network, and now you can see what are the red areas, the green areas, and the orange areas. So what's really bad, what has performance issues, and what are good routes that you can take to get better to the destination. So kind of Google Maps. I like that concept. So I would say the challenge and the benefits of an open, a mesh network, but also distributed network monitoring is that a full mesh problem, so scalability. So if you see for a mesh network, based on the number of nodes, you have n by n minus 1 divided by 2 links. So a lot of redundancy. So you can really, routing for that also reason is really kind of challenging, right? It's more hyper-connected. But on the other side, on the monitoring, if you want to do a full mesh of, say, ping test between all your agents, then you have a scalability issue where you're generating a lot of tests, because in distributed network monitoring, you have their agents and there you have tests. So you have a lot of tests, exponentially they grow. So a way to limit is always like when you have such a solution to identify the patterns that are just good enough to monitor your network. So some users say, okay, I have 300 agents, I want to do a full mesh. Maybe not, don't do it. Understand the pattern and the design of your network, and based on that, configure common tests. You don't need always full mesh, right? So also, if you have a better picture of your network design, you know that maybe you can deploy some tests in hub and spoke. So one agent or multiple agents ping one agent, right? But then in some situation, maybe you have an enterprise network. Now I'm talking about a wired network, but can always be applied to a wireless network. If you have, say, 5 different clouds, AT&T, Verizon, maybe you can take 2 or 3 nodes per cloud, and then you do a full mesh between them. So you can verify reachability between 2 different clouds. So bottom line, watch out with the full mesh testing.
Never go full mesh.
Never do full mesh. Yeah, if you have 5 agents, it's fine, but yeah, watch out. It's going to grow very fast. Yeah. Is it the same with wireless? How many of you have deployed mesh networks? Okay, great. So
Andrew has one in his house.
Do you, like where you live, do you have like a community-based mesh networks?
No, he just has one in his house.
And right, exactly. Yeah, do you see that that is, and then that's the topic for the open discussion, probably I can go next. But yeah, like I would be happy to learn more from you if you see like open, and mesh networks like being the future. You think that will replace eventually like ISP or, landlines, I would say?
So the city I live in, apparently, and this, I just randomly picked the city I live in when I moved back from Colorado to Minnesota, was one of the first communities that had a mesh-based network acting as an ISP.
Okay.
And we just shut it off this year and ripped all the hardware out.
Oh, wow.
And the issue for them is the price. It was a very low cost solution when you compare it to your cable and DSL providers, and it was great from that aspect of it. You didn't have to wait the 1 week to get your equipment. You could just go to City Hall and pick it up. So when we moved to the apartment and then moved to the house, perfect for that type of stuff. But the costs with it, when they looked at the sticker shock of trying to upgrade to latest generation technology, they just decided we can't support it. So I wouldn't necessarily say that mesh networks are the future by any means. I think they're certainly a good option out there for some environments and some locales, but for the most part, a cable connection and a DSL line, and then now that we've got people bringing fiber to the home in, that's probably where it's going to be. The mesh networking really isn't that big of a deal anymore. There's, Andrew, have you ever used USINet in Minneapolis on the community network?
It was all SkyPilot.
I did. I had service from them, but that wasn't a mesh. That was just cable strand mount. No, it wasn't even strand mount. It was just pole mounted hotspot. It wasn't.
I thought some of them were meshed though too.
Yeah, they were. It was SkyPilot. SkyPilot.
Some of them, well, for backhaul, but not for. Yeah, I guess some of them were, but
I see it as a way to provide quick access in the interim until you get a cable ran. Me being the wireless guy here, I love wireless.
For developed countries, yes. For developing countries,
I've got 2 city communities that are all meshed together. I've got, again, RV parks. I make fun of it, but you have very little infrastructure places to run cable. People who don't want to make investments in infrastructure by running cable or copper. So we have some mesh nodes that we overlay with point to multipoint in there. I mean, mesh, I do a ton of mesh. I still do a lot of mesh right now.
Well, and there are point use cases too, like long runs, like for train tracks or transportation. Mining does a lot of mesh.
Road construction when you're doing about miles at times.
I mean, that's really, it's really good for that, I think.
Police and emergency responders. I think how many of those emergency responders are like the fire station, the fire
apparatus,
and they're all like coordinating on-site response through an ad hoc mesh type network.
In my opinion, I think like it's kind of an innovator's dilemma. Like the technology has to kind of kick in and be enough adopted for seeing like disrupting maybe the cable industry on one side. On the other is like. Of course, right now it looks like there are a lot of experiments by people that like technology and want to play with it, and then they have a vision, I guess, or I wonder if in the future there will be someone that can provide something commercially easy and accessible to, I would say, non-engineers, right? Maybe that will happen, because if you think the number of wireless devices now, it's exploding, and something must happen. Probably we're reaching a critical mass where even maybe MANET will be the future, so something. And we're watching that with interest because, distributed network monitoring for us is the same. It goes along, bottom line. And the last one is like a distributed network monitoring first, network automation next. So this is like more, I would say, I don't want to use software defined. Exactly. I didn't want to use that. But the point, if you think, is like a routing protocol does active probing, right? Link state protocols. They basically do that intrinsically. So they build routing tables based on reachability and neighbor information with active monitoring. And a routing protocol, if you want to see it, is like an automation in the end. You don't need to set static routes. It would be unmanageable. Now, a distributed monitoring solution is the kind of on steroids way to verify end-to-end reachability of a network, and hopefully a global network like RIPE Atlas, right? An example. And how about if in the future maybe that data will be used by some super advanced on steroids routing protocols or automation algorithms that can really steer a global network. So that's a kind of feedback loop like a lot of people are talking about, like you sense end-to-end latency and then you adjust your network in an intelligent way, like the overlay network. And maybe wireless could be also another area for automation to kick in more. Okay. Okay, if you have any other questions about distributed network monitoring, happy to answer them. And for wireless, I'm sure you guys have better knowledge. So happy to hear your input on mesh networks. It looks like, as Drew was saying, mostly like individual enterprises doing this type of networks. Is not really like a metropolitan level. But again, really on our side, happy to see what's happening like in Pittsburgh and other like cities like New York or Oakland with this like a kind of open community-driven networks. And actually, if you want to read more, there is a Wikipedia page about wireless community networks. You can see a list there. And I think if someone is building one, maybe add some information there. Okay.
I think I like the product that you guys have, and I think it's, we had a nice little discussion last night where it's not just, it's not about what you guys are doing right now, but being able to use your sensors and your collectors as an endpoint to feed into multiple systems.
Right.
We had a presentation yesterday from Nyansa who has a really great product in a way that they're looking at a network overall. And this is a component, I think, that can marry very well with that, where you could take the data that you guys are doing and combine it into what their bigger picture is and give us just one more tool or one more way that we have visibility into a network. And the question that we were speaking about last night came up on Twitter, and that was, have you guys, I can't remember who asked it, but Javier Solis said, will NetBeast foresee working with any vendors to integrate remote monitoring, even things such as Cisco's RTT Mon probes? So it'd be interesting to see, to see you guys collaborate with some, other manufacturers or different people that are out there to integrate your code. If it can run on a Pi, it can probably run on a couple different devices.
Exactly.
We need to see that take place.
Yeah, there are two types of integration we're looking at, and we're open, with other vendors or infrastructure vendors. One is the agent integration, and the beauty of our agent is really lightweight, so it can run on any kind of Debian-based or Linux-based operating system, which most of them are. And then second, the controller, so the data and the intelligence that is central, right? The agents are just, in a certain way, dumb agents that do monitoring and send data back. So the controller then is really where we could integrate with other tools that manage the network and see more collaboration, right? Kind of the feedback loop happening there. Yeah, so that's a good point.
11AC, right? It's fairly difficult to get good USB 11AC hardware.
Right.
Moving forward, do you guys see that as kind of the next step, or are we going to have to take a different approach as we move forward with 11AC, 11AX?
So 11AC support. Right, so, and actually Panos that is here in the room, he's working on that. Right now we found ABG-N and AC we're looking, because primarily we use the Raspberry Pi, so there is a lack of support on that side. But eventually, like considering another hardware platform and other dongles that will support AC, right? Because do you see a lot of AC deployments now? Is it like breakdown more or less, like gut feeling, gut number? 2080 or more?
And AP in
A long time.
a couple of years.
Yeah, already. And you see a lot of users going towards AC, right? Okay.
That would be an understatement.
Yeah.
Okay. So better hurry up.
As in, I don't see any users putting in.
Okay. It just goes straight to AC.
Right. You make that sound like it's a jump. AC's been around for a while. going back to N is at least 2 generations back.
Ah, okay, so they're putting N and not AC.
No, putting an AC.
AC, okay, and not N.
I haven't put N in
okay,
for
yeah.
a long time.
Yeah, I was confusing, right. Yeah. Yeah, so, yeah, right now we have like the dual mode, traditional 2.4 and 5, yeah. But always looking, and then more requests we have, more we'll, urge with that.